Hello, time to do some geoboard geometry. So we're going to do two things in this problem. And that is first to find the distance around the figure, the perimeter, and then also to count the number of squares inside, right? So we're going to find the area. So this figure is on the geoboard, right, connecting the pegs. And it's also an irregular figure, right? And that's what makes it a little bit more difficult. So first thing is let's find the distance around it. And so what I would recommend is to do the easy ones first. So anything that is perfectly vertical or horizontal is easy to calculate. So this one here on the left, you can see that's 1. This one you can count, right, is 4. So remember here to actually count the distance between two pegs, right, not to actually count the pegs. So when you count this, it's 1, 2, 3, 4, even though it connects 5 pegs. And then the other one here is this vertical distance. So I'll have to count it. 1, 2, 3, 4, 5, 6, 7. So I counted 7 there. So those are easy because they're either vertical or horizontal. So I'll just write these down. So this is pretty simple to get those. But then we still have two others to get, right, to calculate. So we have to calculate this diagonal distance and then also this arc. So you'll remember this diagonal distance, really, we can use the Pythagorean Theorem. So I'm going to draw a line here, just like that, to make a right triangle. So down on the bottom, 1, 2, 3, 4, 5, 6, 7, 8. So this is 8. And you can visually see up here, this is 2. So here, we're going to borrow the Pythagorean theorem to get the length of that diagonal. So we should do that work. So the two legs here are 2 and 8. So if you want, you can call this h for the hypotenuse. So let's go through this work. So h squared equals 2 squared plus 8 squared. And then you can calculate 4 and then 64. So you get 68. So to get h, you can take a square root. So you get square root 68. So I'm going to circle this too because that gives us more of the perimeter. And then the last piece here is this little arc. So we're going to assume this is the arc of a circle. So if we find the center of the circle, we can see it there. And if you find the radius, right, you can kind of see it here. 1, 2, 3, 4, right? So that radius is 4. So I'll do this here. Radius is 4. And then to get the perimeter or circumference, right, we did this in lab. Circumference there we derived as 2 pi r. And the r here is equal to 4. So when you do 2 times pi times 4, you get 8 pi. But then if you look at the figure, we only want 1/4 of the distance around. So we have to divide this by 4. So really the arc that we want is just 2 pi. So now we have gone all the way around the figure, and the circumference will be the sum of these three, right? And that will be your answer. So let's just jot that down. So perimeter here, right, or the distance around. It doesn't matter the order in which you write these, right? So 12 plus square root 68 plus 2 pi, right? So that looks good for the distance around. And remember here that the units, right, if these distances peg to peg were, say, miles, then your answer here would be in miles. So because we didn't have the units, you could just say units, right, whatever those would be in the problem. So I'm also going to ask you in these problems to give an approximation, right? So if you punch this into a calculator, you'll get a rough idea of how large or how big the distance would be. So this ends up being around 26 and a half. 26.5 units around. Right, so that's really how that works. So let's do part 2. So let's answer the different question, and that is how many squares fit inside this figure. So I'm going to use the same figure here. I'll use a different color, and now we're going to talk about area. Okay, so look at the same figure. So you could break this figure into pieces in which you could calculate the area. I'm going to do something different here. I'm going to use a subtractive method to find the area. So I'm going to enclose this figure like this into a rectangle. It almost looks like a square. So we know from the first part already that this height, this entire thing is going to be 7. And then we know going across the top, this is 8. So we already have those calculations. So if you wanted to calculate the area of this rectangle, we have 8 squares going across, 7 squares on the vertical. That's going to give you 56. So we'll start with this. All right, so this would be an over calculation for the area. So now what we're going to do is to actually subtract out the pieces we don't want. So this triangle here is not part of the figure, right, of the original one, nor is this quarter circle, right, that little piece. So what we can do is to calculate the area of each one of these and subtract it, right, take it away from 56, and then you have your answer, right? So we'll just do that in 2 little installments. So I'm going to look up here first, right? This is a right triangle, and the height is 2, and the base is 8. So let's do that. So the area of this would be 1/2 base times height. So 1/2 the 8, and then the height is 2. So 16 by 2, right? This is going to give you 8. So I usually write a note to myself that you need to subtract this away, right? And then over here, this will be 1/4 of the area of a circle, and we can tell that the radius, right, is going to be 4. So again, this is stuff that we're going to use from the lab that we had earlier. So if you want to get the area of a circle, this would be pi r squared, right, that second derivation that we did. But here we want 1/4 of it. So you can either multiply by 1/4 or divide by 4. It's up to you. So let's do the work. So for this quarter circle, it'll look like this, right? So 16 pi divided by 4, this will give us 4 pi. Right, so we've done now all the calculations. And that's it, right? So that's pretty simple. So this is our overestimate. So it's going to be 56 minus each of these, and that will tell us how many squares were in that figure. So the answer here for area, let's write it out first. Okay, so this is what it looks like initially. But this is some simple math, right? 56 minus the 8. So that's what we get for the area, right? 48 minus 4 pi. And an important distinction here is, again, if we measured here peg to peg was miles, then this answer would be in square miles because we're counting the squares. So because, again, we don't have units, we would say units, but it would be square units, right? Those are the things that we're actually counting. And just like the first part, I'll ask you, punch this into a calculator, use pi is equal to about 3.14, and then you can get a rough estimate on what you're going to get here. So just to be complete here, if you want the estimate for this one, I got around 35 and a half. So 35.43, and same units here, right? We're actually counting up the squares. So that's how that works. One exercise in going around the figure, and then a different exercise in counting the squares inside.